Hello everyone and welcome back to the next session on functions. In this video, we are going to have a look at storage classes. So far, we have used primary data types like integer, float, and character. And you know very well that these primary data types would be of several types. And moreover, to fully define a variable, one needs to mention not only the type but also its storage classes. And that is what we are going to deal with in this particular subsection. A storage class defines the scope, visibility, and lifetime of a variable and or functions within a C program. We know that to define a variable, one needs to mention its data type. And we have been doing that since long time actually. But only data type is not sufficient. It also requires storage class. And that is the secret that I'm going to reveal you out as of now. Now, whenever we spoke about data type, we always used to write the syntax as data type followed by the variable name. That is integer, for example, int followed by a, where we used to say variable a is of integer data type. But strictly speaking, the syntax of variable declaration has got an extra feature, and that is nothing but the storage class. And hence, the correct syntax of variable declaration is storage class followed by the data type followed by the variable name. We will look into this as and when we proceed further. Now, what actually the storage class does, or what is the purpose of the storage class as far as C programmer is concerned? The storage class tells us four things. First and the foremost thing what it tells is what is the default initial value, that is the value assumed when the variable is not initialized. You recollect some of the programs that you have done whenever you used to say just a simple declaration statement int a semicolon and you make an attempt to print the value of a, it was giving some junk value, some garbage value. The question that comes in mind is from where did you get that particular value? Because the variable a was not initialized. So that's the first thing that your storage class tells. The default initial value, that is the value assumed when variable is not initialized. Second, what is the scope of the variable? That is in which function value of the variable is available. If you recollect our previous video, we had discussed something about local and global variables, and we have seen how these variables play a role in programming language like C. Third, where variable will be stored, and the fourth thing is what is the life of the variable. So at the end of this particular video, you will be able to get the answers for all these four questions. Now, apart from answering these four questions, actually C supports four types of storage classes. First one is automatic, second one is register, third one is static, and fourth one is global. We are going to have a look at all these type of storage classes one by one, thereby getting the answers for the four questions that we have seen in the previous slide. So let us focus to the first storage class, what is called as automatic. The default storage class. Automatic storage class is actually considered to be the default storage class in C, which is invoked by a keyword called as auto. So we say auto int a. Let us look at the answers given by automatic storage class. Its location is memory, default initial value is garbage, the scope of automatic storage class is it is local to the block, and the life is till control is within that particular block. So what it actually means in a nutshell is automatic type of storage class is considered to be the default storage class. That means what? We have been using this automatic storage class without our knowledge right from the time when we discussed the declaration statement in C. That means what? What you have in front of screen is auto int A. And the moment we say that automatic is a default storage class, I can as well remove the keyword auto. And what is left is int A. And that int A is nothing but it belongs to automatic type of storage class. What I'm trying to say is int A is nothing but auto int A. That is the meaning of default storage class, right? This particular keyword auto is rarely used while writing programs in C language. That is because auto variables can be only accessed within the block or function they have been declared and not outside them. Of course, these can be accessed within nested blocks, within the parent block or function in which the auto variable was declared. Right? Now, every local variable is automatic in C by default. I repeat, every local variable is automatic in C by default, and that is the prime reason we don't use this keyword auto very often. Now, let us code and try to understand how automatic storage class works in C. So as usual, I come back to my online compiler and then let me type a program for you. Auto. Now this is my storage class AUTO followed by the data type. I just say int followed by the variable name A, right? So this is my syntax. This is my example. So I have auto as a storage class. I have int as a data type, and I have variable A as the variable name is A. And what I do is I just make an attempt to print the value of this A, and I say A is equal to percentage D. Okay. Now I have not initialized the value of this variable, right? It is only declared. Now, since this variable A belongs to automatic type of storage class, we have seen in our discussion that automatic type of storage class always gives you a garbage value because the value of the variable is not initialized. So let us have a look at the program output. Okay, that's the syntax error that I have committed, and I'm proud to commit syntax error. I always feel proud to commit syntax error because I always feel that committing syntax error is always C programmer's birthright. So it's just giving me A is equal to 0, right? So it can as such give me any value, any garbage value. In this case, the garbage value happens to be 0, right? So auto int A is as good as writing int A, right? So this is how we used to basically write the declaration statement so far without knowing that it belongs to automatic type of storage class, right? Now, let us try to have a different variation of this. What I do is I just say auto int I is equal to 1. Okay, auto int I is equal to 1. And then I just land up having 3 braces, and then here I say printf slash n I is equal to percentage D, and then I have comma, I say I, and then I say semicolon, and then I come out of this curly brace and I still make an attempt to print the value of I again. So I just say printf, same thing. I'm not going to change anything. I'll have again I is equal to percentage D, and then I say I semicolon. Okay, and let me not waste time in typing. Again, I'll put it as here. So I'll remove this. I don't need this statement. Okay, and this is where I have. So if you look at this particular program, right, I have declaration statement in line number 4, but I have the same printf statement in line number 8, then line number 10 and line number 12, right? But the difference is I have this opening and closing braces for all. This is what I mean to say, local to that particular block, right? So let us see the output, how it works, right? And that is what I have the output in front of me. I is equal to 1, I is equal to 1, I is equal to 1 in all the three cases, right? Now we'll do a small change and we will go ahead in initializing the value of I in different blocks, right? So in line number 4 I have I is equal to 1, and line number 5 I have a block getting started which ends at line number 13. So what I do is I once again declare and initialize the value of I, and I say auto int I equal to 2. And then what I do is I come here and I say int auto int I equal to 3. This is what I do here, and I don't need this particular bracket. So yeah, I need this bracket. Okay, so I have auto int I is equal to 3. So I have this bracket, this is closed, and then I will also have this printf. So let me now compile and run this particular program. Now that's what you see. You'll see the output as I is equal to 3, I is equal to 2, I is equal to 1. Let us understand how this program works actually. Now what happens is when it comes to line number 4, I have I is equal to 1. And then this is the opening of a particular block, and that's the beauty of it, right? So because I'm opening the block here, in the next line it allows me to have the value of I as 2, but that is not so important because variable can always change. But the beauty of this is because of the presence of this curly braces, I can redeclare the variable once again, and that's what I have done here. I said auto int I equal to 2, right? Otherwise redeclaration of variable is not allowed. And then the same procedure follows. I have line number 7, which is nothing but starting of the another block, and hence I have in line number 8 auto int I equal to 3. Now what happens is this is my innermost block where the value of I is equal to 3. So line number 9 will print the value of I as 3, and then this particular closing braces tells two things. One, the line number 8 value of I is lost, and when it comes to line number 11, actually speaking, it has got the value of I, which is in line number 6, which is 2. And hence what happens, this printf will print 3, but this printf will print 2 because this printf is inside the block which is line number 5 to line number 12. And then when the control comes to line number 13, right, it will print the value of I which is outside the block, that is outside line number 5. What is the value of I outside line number 5? That is in line number 4. So I is equal to 1, and hence line number 13 will print I as 1. And that is the prime reason, right? So you get the output as 3, this is 2, and this is 1. Have a look at it. That is the output that you actually get it. Now let us go back to our PowerPoint slide and let us continue further. The next type of storage class is register. It is invoked by the keyword called as register, and the syntax with example is given in front of you. You have register int a semicolon. Now let us see how this storage class register answers our question. The location is CPU registers. The default initial value is garbage or unpredictable. The scope is local to the block, and the life is till control is within that particular block. Now, if you closely observe the answers to the four questions, the location is CPU registers. That means what? Apart from this location, which is CPU register, you look very closely about default initial value, scope, and life. They are exactly same as automatic. Understand? Except the location, which is CPU registers, the other three are exactly same as automatic. Right? Now, this particular storage class, that is register, declares the register variables which have the same functionality as that of automatic variables. Right? The only difference is the compiler tries to store these variables in the register of a microprocessor if a free register is available. This makes the use of register variables to be much faster than that of the variables stored in the memory during the runtime of the program. On the other hand, if free register is not available, see, that is one guarantee that we cannot give, because as a programmer I do not know as of now whether the register is going to be available or not. And that is why I am telling, if a free register is not available, then these variables are stored in memory only. As a matter of fact, when these variables are stored in memory, then you do not really come to know the difference between automatic and register storage class, right? That means when this storage class behaves like automatic, right, we really don't know whether it is going to be stored in memory or CPU registers. Usually, few variables which are to be accessed very frequently in a program are declared with the register keyword, which undoubtedly improves the running time of the program. Let us code register storage class. Of course, I'm not going to spend much time on this because it does not require too much of an explanation. I have to just change the keyword auto to register and then try to print the value of the variable. I'm not going to do all this exercise. I leave it to the audience or the listeners to do it. I just say register int I. Of course, I will not initialize it, and then what I do is I just compile, and let me see the value. It is just giving me I is equal to 0. Actually, it is nothing but a garbage value, right? So int I is equal to 0. I is equal to 0 is nothing but a garbage value that is actually printed, right? The next type of storage class is static. Now, this type of storage class is actually invoked by the keyword static, and the example is static int a. Now, let us see how this keyword static gives you the answers for the four questions. Now, the location is memory, but there's a slight change. The default initial value is equal to 0. The scope is local to the block, and look carefully with respect to the value. Sorry, the life. It says the value persists between various function calls, and this is very important, right? So the default initial value of static is equal to 0. So when we code this particular static storage class, we will definitely get the value as 0, but please do not get confused with this 0 and the 0 we got it in the previous two storage classes, right? That is garbage value, and this 0 is actually the 0. And one more thing that you have to be very careful is the value persists between various function calls. Now, this particular storage class is popularly used while writing programs in C language. These static variables have a property of preserving their value even after they are out of their scope. That is what the life is. Hence, static variables preserve the value of their last use in their scope. We will see this in the coding part. So what I can say that they are initialized only once and exist till the termination of the program. Let us code static storage class and see how it works. So I have here, I just say static int a semicolon, and I just say printf So let me run the program. Yeah, so you can see the value of a is 0. So this is the meaning of the default initial value of static storage class, which is 0. But apart from that, what we have seen is the life. And we made a statement that value persists between various function calls, right? So let me just have a user defined function also here. I just say void increment. So I'm calling my user defined function 3 times, and then I will have my user defined function. There's the definition part over here, and then here what I say is I say static int a equal to 1. I mean, I can also write initialize the value of a variable despite giving the storage class, because there's no hardbound rule that whenever you use storage class the value of the variable should not be initialized. So I just say printf a is equal to a, and then what I do is I just say a is equal to a plus 1. Okay, so just have a look at this particular code. I have a user defined function called as increment, which I'm calling 3 times in the variable, sorry, in the program main, right? And in the user defined function, there's the function definition. I have this increment, and line number 11 I have static int equal to 1, and I'm trying to print the value of a, and then what happens, I am incrementing the value of a by 1. So let us see how this program works. So I have an error in terms of not declaring, not writing the function name correctly. That's fine. Okay, so I think this should work. Yeah. So you have the output as a is equal to 1, a is equal to 2, and a is equal to 3. Look at the output very carefully. A is equal to 1, a is equal to 2, and a is equal to 3. Now let us come back to the program and try to understand. Now what happens is from line, when it comes to line number 5, the control will jump to line number 10 to 14. That is where you have the function definition. And then here a is 1. So this line number 12 will print the value of a as 1. Okay, and then what happens, line number 13 will increment it, and the value of a becomes now 2. Okay, so here the value of a becomes 2, and then what happens, this curly brace in line number 14 will go back to line number 5, and then sequentially it goes down and it will execute line number 6. So in line number 6 you are calling a function, so the control comes here. Now the beauty of this is, once the control comes once again to the function definition, you have this line number 11 which says static int is equal to 1. Now be very careful, because of the fact that this particular variable a is of static storage class, line number 11 will be executed only once, and that too when it encounters for the first time. I repeat, if a variable is declared as static storage class, then that particular line, in this case line number 11, will be executed only once, and that too for the first time when it is encountered. Now already we have encountered when we called, from when we executed line number 5, the value of a was 1. Now what happens when the same function is invoked once again from line number 6? This line will not be executed. It is as good as deleting this line, right? Now what's the value of a now? Line number 12. See here, this a is 2. So this printf will print the value of a as 2, correct? And then this a is equal to a plus 1 will make a as 3. Then again the control goes back to line number 6. Then it will come to line number 7. You are again calling the function which comes here, and then it will print this particular a, which is nothing but now 3, and then a is equal to a plus 1 makes it 4 obviously, and then this curly brace goes back here, and then it encounters the end of the main program, and that is the prime reason you get the value of a as 1, 2, and 3, right? So this is what you mean that value persists between various function calls, right? So initially it was 1, then it became 2, and still 2 was retained in the function, then incrementation made it 3, again 3 was retained in the function, right? So that is how we say the static storage class value persists between various function calls. So I just help you in getting back the program. Okay, so let me once again run for your own benefit. And that's what I have, right? So a is equal to 1, a is equal to 2, and a is equal to 3. Now let us look at the last storage class, that is called as extern. Now, this particular storage class is invoked by a keyword called as extern. It says extern int a, right? Now, let us look at the answers. Location is memory. Default initial value is again equal to 0. The scope is global, and the life is as long as the program's life, right? So that's the slight difference. The life is as long as the program's life. And we have seen this global variable in the previous video. So what it means is an extern variable is nothing but a global variable initialized with a legal value where it is declared in order to be used elsewhere. That's the beauty of it, which we have seen already in the global variables. It can be accessed within any function or a block. But a normal global variable can be made extern as well by placing the extern keyword before its declaration in any function or in any block. This basically signifies that we are not initializing a new variable, but instead we are using or accessing the global variable only. The main purpose of using external variables is that they can be accessed between two different files which are part of large program, right? Even though I said that the scope is global, we have already seen how global variable works. But what I want to emphasize here is with respect to the keyword called as extern, extern. And the emphasizing point is the main purpose of using extern variables is that they can be accessed between two different files which are part of large program. Let us have a look at this extern storage class, how it is coded in C language. So let me write a code for you. Right now, watch out very carefully. What I'm going to do is I'm going to introduce a new concept, and the concept is I'm going to have my own header file, which I'm going to write it here. Okay, so let me write it afterwards. Let me have the main, which I say I'll have what should I say? Let is very simple. Let me have a hello. So I say print hello will be my user defined function, which will be, so that's my user defined function, right? And so that's my user defined function. Let me call it as one more time so that we can understand is much better. Let me call it like this for how many times? 3 times. And then I have my printf statement, which says that function was called. Okay, so maybe I can say percentage d times. So I just say, and then say I say call count. Okay, so call count is a variable. Let us not bother about that variable as of now. And then what I do is I will totally remove this line. Okay, now that's the beauty of this. And then this is a question for all of you. What is that I'm going to do in line number 2? So here what I'm going to do is I'm going to have my own header file, and I say my header dot h. That's the beauty of C, right? So look at line number 1. Line number 1 is hash include stdio.h. You know that it is standard input output, which is a system defined header file. Apart from that, C allows the programmer to have his or her own header file. So I'm just calling it as myheader.h, right? So of course this is enclosed in opening and closing double quotes, and the first one is in the pair of angular braces. That is, the difference is this is always most of the time this will be my user defined header files, and this one will be system defined header files. Okay, so now I have this user defined function print hello, and I have this variable call count. But the beauty is, where am I writing the definition part of the function, and where is this variable call count, right? And the beauty is I'm going to have a new file which I will call it as my header.h, right? So that's the name of my new file, and I say okay. So compiler allows me to, sorry, the editor allows me to write the code or to edit the code here. So what I say is I just say hash include. Okay, so I just say stdio.h, and then just try to recollect that variable which we used in the main part. I say int call count equal to 0, right? So this is the variable int call count is equal to 0. And what was my function name? My function name was print hello. So I just now I have to write the function name here. So I just say print hello. Since I'm not going to return anything, I'm going to write it as print void print hello. And since it is the definition part, I should not have the semicolon. So here what I'm going to say, I say printf slash n hello. Since we are discussing the external storage class, let me use the word external variable, right? So because call count is a external variable, and then what I'll do is, since call count is initialized to 0 in line number 2, I will say call count plus plus. Okay, now see here, this is a file called as myheader.h, which has got my own user defined function called as print hello with certain things written in line number 5 and 6. But then this particular header file do not have main, right? That's the beauty of it. I'll go back to my main program where I have this main, and then I'm going to compile this program and run this particular program, and let us see how the output behaves, how the program behaves and gives you the output. Let me run the program. Wow, that's beautiful. You see here, hello external variable, hello external variable, hello external variable, and then the output is function was called 3 times. So the output is these 4 lines, right? Now function was called 3 times. Let us go back to the program and try to understand. Now what happens is, whenever you make an attempt to compile and run this program, the header file called as myheader.h also goes with this particular program, right? The entire source code is converted object code, and then what happens, line number 5, you're calling a user defined function called as print hello. Then what happens is the system will branch its control to myheader.h, because that is the place where you have written print hello, right? And since the variable call count is equal to 0, right, the line number 5 will get executed for the first time, and then call count becomes 1. And then again you are executing line number 6, it goes back here. So print hello external variable will be printed second time, this becomes 2. You go back here, you are calling the user defined function for the third time. What happens is print hello external variable will be printed for the third time, and this becomes 2. Sorry, this becomes 3. and then what happens, you come here and then it says that function was called how many times. Call count value is 3, and that is the prime reason you get the output as like this: function was called 3 times. Got it? So that is how basically a keyword or storage class extern works in C programming language. Now, let me conclude the storage classes. The storage class concept is very much useful in C programming language because a user can define the visibility of every single variable in the program. Apart from that, a user can decide the lifetime of variables using these 4 types of storage classes depending on the requirement in the code. At the end, I would like to tell you one thing, that according to Dennis Ritchie, C programmer is in a best position to decide which storage class has to be used and when.